adding everybody now. Here they all come. Hey, we've opened the doors and everybody's running in. There we go.
Floodgates are open.
There we go. Okay. Good morning, afternoon, evening, wherever, whatever it is, wherever you are. Thanks for coming to another Tech Talk. I am really happy today because we have got two of the stars of CodingNomads here. We have our charming co-founder, Kim Desmond. She will be driving the bulk of the talk today, and she will be talking with Michael Darling, who we see up there. Michael is a research scientist at a prestigious national laboratory. When people say, when you hear somebody say, we have our people working on it, that's Michael. Michael is the person who's working on it. So this is going to be all about Michael's job as a research data scientist. And so I would like to get a kind of a feel for folks, what you think, what you know about data science. To start off with, if you are a complete data science newbie, could you, using the reaction button down in Zoom, could you just raise your hand, give a thumbs up, do something like that? If you're a complete newbie, so we've got 1, 2, 3, 4, 5 of us, because I'm a newbie here as well. Great. If you have some experience, could you maybe do the same thing? Again, either a hand wave or a thumbs up. Ryan's got some experience. Prisha's got some here as well. Okay. If you really know what you're doing with this stuff, you know, you've done R, you understand data science really well, go ahead and do the same thing. Okay, well, I'm assuming nobody else really knows it all that well. I know Michael didn't raise his hand either, so this is going to be an interesting hour. So, okay. So without further ado, I'm going to turn this over to Kim and Michael. Kim, take it away.
Thank you very much, John. Yeah, and so, you know, we thought we would structure this as kind of an Ask Me Anything about data science. So I'll be leading most of the questioning at the beginning, but if anyone has a question, please feel free to pop it in the comments box. If you need some clarification or need a little bit further explanation on anything that Michael's talking about, just pop it in the comments box and we'll either address it as it comes up or we'll wait till the end to take questions. But, you know, we definitely would love to hear from everyone here too, to get all your questions answered about data science. So thank you everyone for joining. And I'll go ahead and get started with, you know, it seems like most people on the call are kind of in the beginning sections of data science, or maybe just curious about what it is. So maybe, Michael, we start with just a really general definition of what is data science and, you know, what is a data scientist?
Sure. Can you hear me okay?
Yep.
Yeah, okay, great. So it's a really difficult question to answer because I think everybody has their own definition. And if you look at job requisitions on LinkedIn or what have you, you will see very different things from job to job. So it's a little bit like asking what is science? But it is obviously science of data, right? So I think anybody who is running experiments with data would be a data scientist.
Okay. And so why is data science so, I mean, it's a big buzzword, but it's also a huge industry. It's, you know, at the top of the best jobs list for 2022, and everyone's kind of curious about it. So like, what's all the hype about?
I'm still trying to figure that out myself. I think, you know, computing has gotten cheaper and faster, bigger over over the last 20 years, so that organizations can store and collect massive amounts of data that would not have been able to do prior, maybe even 10 years ago, right? And so as you collect this massive amount of data, then, well, what do you do with it? What can you learn from it? How can we make our organization better? And for most organizations, not mine, but for most, it's how do we exploit it to make more money, of course. So I think that's why it's become so popular. You are, people are still trying to figure out, given I have all this data, how can I use it to make better decisions?
Okay, so data scientist is the one who figures that out, how to make better decisions with data.
At the risk of being reductive, I'll say yes.
Okay, well, maybe let's get into more of the specifics about your particular job. So I know that you're a research data scientist at or at a research lab. And so maybe you can talk about what your day-to-day looks like and you know, what data science kind of means in your particular role.
Yeah, it's a good question. Still, again, still trying to figure that one out. So, part of what goes on here is that you see that like you have a role called data analyst, a role called data engineer, a role called data scientist, and there are tasks and things to do distributed across those three roles, but who does what varies from organization to organization. And so in general, the analyst is someone, looking at the data. Actually, I shouldn't speak on that one because I don't fully know the answer because we don't have data analysts at my work. Basically, people with my designation have to do everything or just whatever is needed to be done. We have to do it. We don't have designations like that, right?
Which is probably true in a lot of organizations. I mean, there's all these different, there's data analysts, data engineer, data scientists, but probably for most organizations, especially small companies, they can't afford to hire one of everyone. So maybe the data scientist just gets kind of blanketed with everything.
I think that's right. Although I do think there is an effort to take some of the engineering aspects off the data scientist. The term data engineer is something I've heard more recently, and I think their role is going to be taking raw data, processing it, putting it into structures where it can be queried and organized and such, and get it ready for the data scientist. Again, this conjecture because I don't have firsthand experience on that. Like, if there's something to be done with data, I just have to do it. Maybe I can get an intern to do it, but I still have to figure it out, right? I don't have a data engineer to turn to. So people are fully welcome to correct me if I'm wrong on any of this.
I'm sure it varies from organization to organization too,
absolutely,
like you mentioned.
Absolutely. But you asked, so me specifically, so yeah, we do research, and I guess it's a good question. What's the difference between data science and data science with research? But I think the main difference is that we are trying to figure out like new tools to use with data science or new approaches rather than using standard approaches. But even then, the designation is pretty wishy-washy because again, if you're doing science, then you're doing what it takes to get something done, and that could look like a lot of different things. But anyways, day to day. Good question. There's a lot of different things that could be happening. So probably the most interesting and fun aspects is we usually use something like Python. We use Python to construct proof of concepts, proof of principles on data, trying to solve some problem, some question somebody has. And learn things from the data, try to use the data to predict new things, that kind of thing. But there's still a lot of other things going on. So our lab kind of sits somewhere between industry and university. So you kind of get the best of both worlds or the worst of both worlds, depending on which day you ask me. The so we have the ability to say write proposals for funding to try new things, right? Kind of like a university. So that's pretty cool. But writing proposals is probably the least favorite thing I do. You just gotta like spend so many hours trying to construct the perfect paragraphs to try to make people understand why they should give you a lot of money, and that's not easy. But there's also a lot of presenting results, so a lot of communication, right? So we have to write reports. We publish papers, conference papers, journal articles, things like that. We have to present the work to people who don't have background in data science. So that's a big challenge. I don't know if you're familiar with the Richard Feynman's technique for learning. There's several versions of it out there online, but the one I like is so basically I can't remember the steps exactly, but you define a topic and then you learn something and then you try to explain it to someone and then you refine your knowledge and kind of there's like a cycle like that. But the version of it that I think of is when you try to explain it to someone, the question is, how would I explain this to a child? I'm not going to say that's what happens when I'm explaining it to managers, but something like that.
Mature children, educated children.
There you go.
But I guess being able to simplify it so that anyone can understand it, even if they're not an engineer or a scientist, you probably have to explain it to the financial people and the decision makers.
Exactly. You have to explain it in a way that makes sense and why it matters, and why it matters doesn't require any jargon or any specialized knowledge to understand, right? If it's explained properly. I mean, it's kind of like there's a quote that's attributed to Einstein. I'm not sure if it's actually Einstein, but if you can't explain something simply, then you don't understand it well enough. And I think that's very true.
Yeah.
So
well, communication is, that's a whole different skill set. I definitely want to talk about your education, and we've already had some questions about, different platforms and tools. You mentioned tools, but it's interesting that communication and kind of these soft skills is bubbling up to the top of one of the main things that you do every day.
Yeah, and that's not what I would have expected when I was in school, because we definitely don't focus on it at all. I mean, maybe we had one class in my undergraduate degree where I think it was called like Intro to Tech Writing or something like that. But that's it, and even that was questionable how useful it was. And yet, I find myself spending a lot of time with PowerPoint, or other ways of constructing presentations, or writing reports or a paper, trying to communicate the ideas to people that don't have my background. And even people who do have my background or similar backgrounds. I mean, we all end up specializing in niche areas. It's a very undervalued skill set. Anyways, where were we?
Okay. Well, we were talking about some of the skills that you use. So, talking about the soft skills, and then, I know some people are curious about also like the hard skills, the technical skills that you use.
Yeah, so me personally, it's a lot of Python, and there's a package called scikit-learn, which is a very popular data science machine learning package in Python, package of tools. Other people, I don't really do anything with deep learning, but other people are using things like TensorFlow. Pretty much the most popular things out there. And then in addition, there's been some capabilities that I developed on my own with Python that I use in my analyses. So yeah, that's about it actually. Because usually we're dealing with, like I said, proof of concept, so it's a relatively small data set, so I don't have to worry about like big data, whatever that exactly means. I don't know where the cutoff from small to big is, but it's usually data that's small enough to run on my machine, that doesn't need a cloud or anything like that. Import it as a CSV, run some analyses, and then get some pretty pictures and graphs and charts and such. So the tools itself is actually pretty simple. And then mostly we're just trying to ask interesting questions of the data and things like that.
Nice. Yeah. So we have a couple questions that are, on this topic. So I figured I'd go ahead and address them. Senate asked, how much, if any, does the use of informal logic enter into your work?
Informal logic. I think I would need a definition on what that means.
All right, Senate, if you want to, you could either unmute yourself or you can type into the messages.
Well, I'll try and explain. That's kind of embarrassing because I don't know that I could explain it, but it's the stuff that's not mathematic and it's the stuff that's not symbolic. It's more like the Aristotelian kind of, syllogisms and things like that.
That was some words I don't know the definition of again.
I think that's my answer.
I mean,
at least in this particular field.
I mean, I want to say when you, on its face, when you say how much informal logic do we use, I'd say a lot because if you define informal logic at throwing stuff at a wall and seeing what sticks, there's a lot of that. But I don't think that's what you meant. So
It kind of is. I appreciate that.
Okay, good. I mean, because at some point it's experimentation, right? And what you do in practice doesn't match theory, right? And so you got to try stuff, and the math breaks down and it doesn't work, and so you just try stuff and see what works, and then try to explain why or why not. Hope that answers some question a little bit.
Yeah, thanks very much.
Yeah, you're welcome.
We also have another question from Kat, and this is along the lines of a question that I wanted to ask you too. Kat's question was, do you have an example of a paper that you published, or what was it about? Or, can you just give us an example of something really cool that you did at work that you're really proud of?
So yeah, there's a few things. The one that comes to mind, it's a problem that I've been using on and off for like 6 years now, which is looking at malicious website detection. So there's a lot of different varieties of that, but you could start with just examining a URL and looking for something suspicious. And I think probably most of us have gotten an email where there was a link in it, and if you looked at that link really carefully, you notice that something's off about it. Yeah, like phishing, exactly. So if you see, for example, a link that says www.google.iwantyourdata.com, obviously Google is out of place. So it's actually a problem I started working at school with Gilad, actually, who is the creator of our data science course. And we actually, there's an exercise in the data science course where you work on this problem. What was the point? But anyway, so you're trying to train a model to, just like a human can spot the irregularities or find suspicions in a URL, you're trying to train a machine learning model to do the same thing. And we found about, give or take, I think about 80 different ways to measure a URL, if you can believe that. maybe 79, something like that. So, it starts with obvious things like what is the length, what is the length of the host name and the path, and the different aspects of the URL. But it got a little more complicated. Like we created a language model of good URLs, which we took language models that would normally be used for a language like English, and modeled URLs as such. And then you're able to see that not malicious URLs have patterns that don't match the language of good URLs. Interesting stuff. Not as complicated as it sounds, actually. But that was the first paper I published with Gilad. So I'm pretty proud of that one. But I've still been using that problem as an example from my work on and off the last 6 years. Like, okay, now that we can predict what is the probability that this URL is malicious, how certain are we in that probability, right? So you can get the model to say, I think this URL is malicious with 75% probability. Well, what does that even mean, right? Like, how do we know that 75% means anything? We don't. We can maybe try to figure out if that means anything. But the other thing we do is try to measure the uncertainty. So how certain is that 75%? So it's kind of like if you ask me, is it gonna rain? And I say yes. Okay, well, is it gonna? What is the probability it's gonna rain? And I say 75%. And you say, well, how do you know that? And I say, because I looked out the window. That's not very good evidence, right? There's a lot of uncertainty in my answer. I'm not really qualified to give you an answer. I am not a meteorologist. And you were asking me about the weather in Texas, and I'm not even there. And I looked out this window. So sometimes that's what the model is doing. It doesn't know what it's talking about, and it just tells you something. So a lot of my work has been in trying to understand, is the model trained well for a particular question you're asking it, particular prediction, how much uncertainty there is in that prediction.
How much
I think I just answered a question. I think I just answered a question you didn't ask, but anyways, it's interesting nonetheless.
Yeah, no, it's interesting to hear the kind of stuff that you're working on, and especially understanding that it came, you started it in your education path, and then you're still working on it today, because sometimes there's a disconnect between what you learn in school and what you're actually doing on the job.
That's right. A lot of times there is, and that's why one of the cool things about my job is that I have a lot of freedom on what I actually work on, and so I'm able to bring in a problem that I already know how to work with, which is pretty cool. I'm still, and then then we can publish multiple times on that problem, because we're looking at it in different ways and you're trying different approaches with it. I think that was the original question, so I just brought it full circle somehow.
Good job. Cool. Well, let's talk a little bit about your education background and your path to becoming a data scientist. I know, you had one way of going about it, pretty education heavy, and there's other ways to go about it. And now you're seeing that working with CodingNomads, seeing our students go through data science in a very different way. So, what spurred your interest in data scientist? And maybe you can give us a kind of synopsis of how you got to where you are today.
I'll try to not talk too long, because I could easily tell you a lot of stories pertaining to that question. But I didn't really know what I wanted to do. I went to school because I needed a job. I needed a job because I needed money. I think that's kind of most people's story. But I didn't really have a real sense of it. I just picked computer engineering because I thought, wouldn't it be cool to know everything there is to know about a computer? Actually not cool at all, very geeky, but that's what I thought.
We think it's cool. It's cool here.
There you go. and I still didn't really know what I wanted to do after 4 years of school. I learned some interesting things. I suffered some really difficult classes and and such. And I never saw myself actually going to graduate school, but I pretty much only went to graduate school because I didn't really know what else I wanted to do. And the first interview I had after I finished my bachelor's degree was a disaster. Basically, it was I was at the time I was working primarily in Java, and I have a bad memory. So you know, and really, programming is not about remembering every command and you know syntax of this line, that statement, whatever. Really, it's about the logic of it, right? And solving a problem. So my brain just naturally doesn't remember things it doesn't need to, right? That's what Google is for. So I decided to go to graduate school.
Just to prolong that process.
Yeah,
The
just
interviewing process.
to avoid having to get a job. I went to graduate school, exactly. I started graduate school really not knowing what I wanted to do. You know, I just joined as a computer engineering master's student, and I didn't really figure it out until I took my first machine learning course. I ended up finishing my master's with a concentration in computational intelligence, which is not nearly as impressive as it sounds.
Sounds pretty cool.
Anyways, well, so then I went for PhD. In one way, it was a way of avoiding actually having to go and get a job. I should stop there and let you ask the next question.
Well, so it's interesting to hear about your journey, and I know a lot of people wonder, well, is that necessary? You know, there are a lot of jobs that still say they want a undergrad in computer engineering and a master's in XYZ or statistics, or, you know, like how important is it to have a degree or an advanced degree, or is it, you know, is it anymore?
I think it somewhat depends on what kind of job you want. You know, some jobs, of course, still require those, but I would say those are in the minority these days. And again, I thought, you know, I get a PhD, and you know, data science is hot, machine learning is hot. I have a PhD in that. Somebody's gonna be begging me to come work for them, and that's not what happened at all. And I think what it really, and in fact, when I was looking for a job a couple of years ago, I was looking at all these, you know, job requisitions, I think you call it. Is that what you call it? No. And I looked at the skills they want and the amount of experience they want in these skills, and I was not qualified for any of them. So
even after all that school.
Yes. I mean, you know, the joke about engineering school is anything practical you have learned will be obsolete before you use it, except for the complex math, which you will never use. So, so I think most companies these days care more about skills, and you can put it on your resume. I saw another internet blip.
We're back.
We're good. Okay. I hope everybody. What I was saying was.
Talk about...
Yeah, go ahead.
Well, I think we're both, you know, talking about the skills. Like you said, when you read a job description, it was a bunch of skills that you didn't have. So what are those kind of skills? Like, what is actually required to actually get a job as a data scientist? Like, what are the skills that you did need?
Yeah, so a lot of times what you see, I mean, like I said earlier, you know, mostly I use Python and scikit-learn, and when you look at the jobs, a lot of times they're asking for a programming language such as Java, or they'll even say such as C++, Java, Python, right? They kind of just want you to know really know one language, because the secret is once you really know one language, you can pretty much pick up any of the others. Because what you're really learning is the logic on how to problem solve, and how to do it in one language or the other is a matter of Google. Although I don't really want to advertise for them, I'll say search engineering. We need to figure out a different verb. It's a verb, right?
It's everything at this point. Yeah.
Yes. Yeah.
Can I
Scary.
pop in maybe with a quick question, or just to expand upon that?
Go ahead, Ryan. Yep.
So because you mentioned that, and I had this very similar feeling when I got out of university with a computer science degree, that I was heavily underqualified for the actual job. Or when I got my first job, I realized I knew Java and a little bit of databases, and that was it. And I realized that was just a small part of the job. And you mentioned after all your education, you felt the same way in many ways. And so what could you highlight some of those things that you, when you got to the real job, were like, wow, this is totally new, and you kind of had to figure it out on the fly, for instance?
Yeah, I mean that Python. I mean, I basically knew Java and a smattering, a little bits of other things. And the first thing we did when I got my internship was in Python. So I had to basically learn Python on the fly. I was basically Googling, damn it, I said it again. I was basically looking up every line of code. It's like, okay, I need to write a loop. I know how to do it in Java. How would I do it in Python? And so obviously it's a little bit slow to work like that, but then you pick up Python after a few months. And I mentioned scikit-learn, and again, the truth is, once you really know the logic behind how these things work from like if you know one programming language and one framework, and framework for anything, right, that you're trying to do. Like if you know a framework for website development, you know a framework for data science. And once you know one language or one framework, you can pretty much pick up everything else as you need to. I think you would agree with that, Ryan, right?
I would,
yeah. So if you know, so for example, I know Python and scikit-learn. If I were to get another job and somebody said to work in R, I don't want to say R. I had to do one thing at work with R, and I really didn't like it. But and mostly because it's really slow. But that's another topic. But yeah, if somebody were to ask me to work in Java and use some other package, I don't know what data science package is available for Java. But let's say somebody wanted me to learn TensorFlow. I think at this point I can figure it out. So really, if you know one, I don't know if would you call scikit-learn a package of tools or a framework. Either way, if you know that and you know one programming language, then you can pretty much pick up whatever else you want to know.
Nice. So we have a question which kind of goes in concert with this, is how long does it take to become a data scientist? You kind of talked about your path, but I know that you've seen alternate paths.
Yeah, it's really hard to say. I think that, so if you go with my idea that one language and one package, depending on how much work you can put in, that's a matter of months. And I've seen students start from no programming background whatsoever and make a lot of strides in a matter of months, to the point where they seem just as competent as I did after 12 years of school. So I sometimes I'm wondering, was it all worth it? That many years in school. So yeah, I think, like anything, how much time you can put into it to learn, everybody learns everything at a different rate. I actually consider myself a very slow learner, actually. Like I think my brain wants to know more than it needs to before I can actually work. And so where some people are really good at just like picking out the important bits and going. So the time it takes for me to like fully get my brain wrapped around something and then work with it takes longer than a lot of people that just pick things up. So you know, a lot of it is individual. Kat says,
Sure.
"Oh my God, I'm the same way." Yes, exactly.
I tend to be like that too.
Yeah.
I like to understand the full picture.
Yeah, which I think in some ways is good, and sometimes that helps you. In some ways, it makes it challenging. So it just, you know, it depends on the context.
Yeah. So we've got another question from Ron about how much math is needed. Is it just a matter of knowing what linear regression is and a little bit of matrix math, or do you need a lot of statistics, R, etc.?
Again, I would say it really depends, and that's pretty much probably my answer to everything that we're talking about. But a lot of times you don't need any math at all. A lot of data science is working with tools and understanding how to set them up and work with them, and then interpreting the results. And you know, how much math I actually use is very little. I think, you know, having some understanding can be helpful, but not necessarily. There are jobs out there where that are going to be math heavy, but again, I think you know, even I've forgotten every math class I have ever taken. I don't remember how to do hardly anything. If I really need to, the few times I've needed to do some math, it was actually math that I didn't study. I actually never took a statistics course, which although I wish I had. And so then I just kind of have to sit down and figure it out, and when do something on the internet that's not Google searching. I have to figure out what that word I want to use. You know, and then just, you know, just look it up and figure it out. So again, it's whatever math you need, I would say is the same problem solving skills that you would use in programming. So whether you learn math first and have that help you to learn programming, or you learn programming first and have that help you to figure out math, it's kind of the same thing, because you kind of learn it by osmosis, the kind of the logic of it all. And so I don't have a good answer for that, but I would say that math, you don't really need it to work with these tools.
Sounds like more of a need to know than or
yeah,
need to know rather than have to know, like on a need to know basis.
You pick up what you need to know as you go, I would say, and none of it is. I would not call myself good at math. I in fact, I tend to avoid it, which puts me a little bit at odds with some people at work. But again, I'm an experimenter. I like to try stuff, and then if I figure something out, then I might try to figure out some math to explain it, or work with. But there's always other people, right? Like I can go talk to a statistician if I need to, and so I don't necessarily need to really know it myself.
Yeah, so I guess maybe the point here would be, you know, if, for example, people who are listening to this talk, if you're interested in becoming a data scientist, think about what aspect of data science actually interests you. You know, if you love math, then you could look for data science jobs that require a lot of math. Or if you don't love math, then you could look for data scientist jobs that don't require a lot of math, because it sounds like there's a little bit of everything available out there, and then just kind of tailoring your skills towards that particular job that you are really interested in doing.
Absolutely. I mean, like there's a lot of data science that is there's a lot of data science that is more about understanding the data, visualizing it, figuring out what to do when data is missing, or what to there's, you know, how to they call it data cleaning, basically when you've got weird, you know, irregularities in the data, how to deal with it and things like that. So there's a lot of skills and tools out there that really have nothing to do with math. Maybe I'm being a little bit extreme in my answer, because I mean there's definitely like basic math, like what's the average of something, but not, nothing that
Not like
I think.
calculus.
Yes, I have not. There's really not much calculus going on, or none at all, really.
Yeah, and actually, John Fincher wrote in a nice comment in the chat box that speaks to this as well. He says, "I think Michael's comment on higher level math and ability to program leading to generalized problem solving skills is important here. The general skills you pick up when learning these specific things is more important."
Yep.
So thanks, John, for that comment.
Yep.
We have another. Oh, sorry, go ahead.
Oh, I was just going to say sometimes, there's a meme that says, "I'm not sure if I'm good at programming or good at Googling." And I do think, like I tell my students, like, I think really what I'm here to do is to help you learn how to ask the right questions. And so, when you learn the logic of how these things work, then it's just a matter of Googling all right, I give up. Of Googling the right thing.
Just give in.
They win.
They got us.
Just a matter of Googling the right thing.
Yeah.
Do you think that's the difference between Google's relative success compared to Yahoo? Like, they were both kind of even maybe 20 years ago, but you don't Yahoo something. So
yeah,
like
Yahoo,
if Yahoo had just picked a better
verb.
name, right? If Yahoo just picked a better name, maybe they would have been the ones to take off, become the standard. Anyways, yeah, I wouldn't want to Bing. That's
yeah, we're not binging. Yeah, well, I think that's a good point that, and this comes into play in programming and data science and interviewing and on the job. You're not really expected to know every single thing. There's no one out there who knows every single thing. And so it really is about figuring out what are the right questions to ask and figuring out how to find the answers to those questions by whichever search engine you'd like to use.
Yeah, and Ryan has that example he likes to bring up of hiring someone for a software position who didn't have background in software, and because I would do the same thing with data science, which is really what I'm hiring for is someone I can work with, someone who's going to be very clear about what they know and don't know. And do what it takes to figure out the stuff they don't know, whether it's Googling or asking someone. And I think that's the most important thing. So out of insecurity, we might pretend we know something or and things like that, and that's actually not helpful, right? I'd rather you tell me you don't know something, and then I can show you, and we can talk about it. So that's really what we're hiring for is that kind of drive to figure things out, and not give up. And that's if someone has that quality, they'll figure anything out.
Yeah, there was a question earlier in the comments about what's more important, hard skills or soft skills. And I mean, sure, hard skills are important. People want you to be able to code Python. People want you to understand how to use data science tools, but it does sound like attitude and motivation and just the drive to figure it out are almost just as important.
Well, and it starts with in the interview is can we talk? can we interact and feel comfortable? And which in some ways is not necessarily the best thing, right? Because I'm sure there are people out there who don't have good social skills, who are amazing scientists, but they don't. Unfortunately, in this world, social skills get you a lot. Just people feeling comfortable working with you and talking to you. And so, fortunately or unfortunately, I mean, that's another topic. So he starts with an interview. Can we have a conversation? Can we talk through a problem together and solve it together? I mean, really, that's what you want when you hire somebody.
Yeah. Well, we have a couple more questions here that I want to get to from the comments. So from Dr. Wahid, he says, or they say, sorry, I attended 3 months of data science course. I learned Python, machine learning, SQL, etc., all within 3 months. After the program, I'm still trying to find the confidence to apply for a job in this condensed training. I'm a physicist. I'm familiar with old Fortran 77. Nice. What advice can you give in order to develop myself in the field to be able to land a job? And then there's another question from Julian about projects or portfolio. And I think maybe those can kind of go hand in hand.
Sure. Yeah. So so we talked about companies wanting to hire for certain skills. So, the best thing to do is to demonstrate that you have those skills. And probably the best way to do that is with GitHub, develop some projects, put them up on your GitHub, and figure out how to display them nicely, maybe write a blog about them. I'm actually not sure how to do it, but you can actually make your GitHub have a nice interface web page to show things. I don't know if people are familiar with Kaggle.com, but it's a very useful resource. There's a lot of data problems there. You can pretty much find any kind of data that you're interested in, right? Now, if someone's a physicist, I had a student who was a PhD in physics, and he ended up getting a data science job that was related to spectroscopy, if I can pronounce that correctly. So he was able to combine data science with real science, physical science. So both his background in physics very much served him for that particular job. And if you're interested in getting a job in a particular area, like I have a student right now who's interested in getting a job in energy, so he found a solar energy data set on Kaggle and did a project on solar energy and put it up on his GitHub. So if you identify the company or family of companies that you're interested in, and if you demonstrate that you can do the things that they would like, if you find a project that they would think is cool and useful to them, and you develop a portfolio for them, chances are you're going to get yourself an interview at least.
So what does an entry level data science portfolio look like? Like you mentioned Kaggle, that people can go on there and work on projects and get data sets. What is it that an employer wants to see when you go to them and say, here's my portfolio? What would be an example of an impressive portfolio project?
That's a difficult question to answer. I don't fully know the answer. And part of it is because I don't work at a company like that. But I would say definitely people care about exploratory data analysis. Can you explain the data or generate graphics and charts on the data to show what's happening in there? And if you do one project really well and really completely, I think that's probably more impressive than a bunch of little projects that aren't really done. I don't. Maybe Ryan is better equipped to answer this question, but I would say if you had 2 or 3 really complete nice projects there, that would probably look pretty good. But I don't know if you can really put a number on it.
Yeah, just to kind of jump in there, I would say at least a few nice projects on your GitHub that show professionalism, because in a project it's also really quick and easy to determine whether the person that wrote this is professional or amateur in kind of how clean, organized, documented, commented, and polished the project is. Like you can have a beautiful project up on GitHub that doesn't have a README or any comments, and it's essentially kind of useless in the whole job hunt portfolio building. But you can, you take that same project and you add a bunch of polish and a README and documentation, adds a lot of points. And then real quick, just since I'm unmuted and chatting and we're running up on our time, there was a couple questions, Michael, that were asked that I'd love to just get like bullet point answers to. You know what I mean? So like, what is the difference between a data scientist and a data engineer? Carell asked this.
Again, yeah, again, fuzzy definitions there, but I would say in general, a data engineer is someone who's taking raw data and processing it and putting it into data structures, data warehouses and such, in a way that makes it easier for others to query and access the data. I think that,
Yeah.
and data scientists would be the one that takes that data and analyzes it and experiments with it. I think that's right. But again, very fuzzy definitions there.
I would agree with you. The engineer is more of like the nuts and bolts. Where does the data go? How do we get it? How do we process it? How do we put it in the right spot for the data scientists and machine learning engineers to then tinker with? And another one
Yep.
would be, Julian asked, what skills or platforms would should a data analyst master? And you know, I can quickly pop in there and say SQL for data analysts is really important, right? A lot of data analysts, that's like the primary thing that they're using is SQL and databases. But do you have any?
Maybe Tableau.
Yeah, Tableau. There's like those
Uh,
BI business
Mhm.
intelligence platforms that give you all those data analysis tools.
yeah,
Tableau is definitely the big
and
one.
I'll say that I'm not really qualified to answer that question because I've never worked with data analysts. So I
No
don't
worries.
fully know the answer to that. But I think that's the best answer I can give.
Cat B asked, do you have an example of a paper that you've published? Would you be comfortable sharing a link to something that you've published? We've got some interested readers or been a part of.
Yeah, we could. Yeah, we could do that. Yeah, so you can actually, Google has a feature which I don't know if everybody knows about, called Google Scholar. And so if you look me up there, you can find my publications.
Oh, there it
And
is.
yeah, and I like to think that my papers are easier to read than a lot of the things you find up there, but you're welcome to contact me if you have questions on any of that.
Nice.
Yeah, Ron put a nice comment in the chat about another skill I notice in good engineers is they're concise and conscientious about ambiguous sentences, such as how something can be interpreted differently that they meant. In other words, they're clear, complete, and to the point. As an example, the answers on Stack Overflow that have been accepted. So that goes to your point, Michael, about the data scientists who get the most projects are the ones that are the best at pitching them or writing the proposals, and the instructors or the professors that get the most funding are the ones that are best at writing proposals. And Ryan was mentioning the best portfolio projects are the ones that have good readmes and comments, and they're kind of concise and clear and to the point, but also comprehensive. So that goes to
Yeah,
the point of soft skills.
and actually, when you bring that up, it reminds me of what I was thinking when Ryan said that. So I think for a data science GitHub, if someone were to present the results of the work they did on their GitHub as like a report or a some kind of presentation that walks someone through what we learned in the analysis, I think that would be really strong, right? Like I don't want to look at anybody's code. Maybe some people do. I don't. I don't want to look at my own code. It's ugly. But if you are able to explain to me in a way that doesn't make my brain hurt, why what we can learn from this data and what we found out, and what's interesting about it, that's awesome. I mean, it's not easy to do it. Like it's funny, Ron is talking about conciseness and stuff. I don't think I'm very concise. I think everything I tend to go, there's two sides to every story, and there's always different definitions for the same words and so many ways you can go with something. And so I think that but yeah, that's the challenge, is taking this complex ideas. I mean, really, when you look at the most important work, let's say like Einstein, right? Relativity boils down to E equals mc squared. It's so simple. Now, to get there and the ramifications of that is very complicated. But it comes down to that. And so when you get to E equals MC squared on your data analysis project, it's like, yeah, that's it. It's simple. It's elegant. It's hard to get to. It takes a lot of work to get to the simplicity, to wade through all the complexity. And I feel like that's what comes out of my mouth when I talk, is a lot of wishy-washy, yes, no, maybe, it depends. So, because it is fuzzy and unclear. There's a lot of uncertainty related to data science, and some people feel very uncomfortable with that. And I don't blame them. Sometimes I do. But you kind of just have to embrace the uncertainty and realize that you're never fully going to know what you're doing. You just got to try stuff.
Great. Well, we are a little bit over time, so thanks everyone for sticking around. If there's any other questions, this is the final call, last call for questions. Otherwise, I'll go ahead and pass it back over to you, John.
And
Awesome.
I saw Ryan post Samuel's project in the chat, and I did reference Samuel earlier. He did a really nice project on solar energy, so I do also recommend that as a good example.
Michael, thank you. Appreciate you taking time out of your day to sit here and talk with us, answer questions, have some fun. Kim, thank you very much for driving the conversation. I hope that we're going to do this one again, and I definitely want to have at least one, if not both of you back to do this one more time. There are a host of questions up in the chat. In my window, it's over there. If you will grab a hold of those and make sure that we've got the answers down. If you have other questions, go ahead and fire them off. You can fire them off here in the chat for the next minute or so. And if you missed that, don't be afraid to drop them into Slack or in the forum, and we will certainly get to them. We've been recording this call. We will get that recording up and posted just as soon as we possibly can. So if you missed it or you know somebody who missed it, you can let them know when it is. Other than that, we're going to have another one of these talks in 2 weeks. I'm not sure what it's about. If there's something that you want to learn about, something that you want to know about, or something that you want to talk about, please reach out to me. I'm on Slack, John Fincher. Happy to talk with you. Happy to get your input, and happy to, if you have something you want to talk about that you know about, I'm happy to get you all set up and let's get that going. Until then, Michael, thank you again. Kim, thank you again. And everybody else, we will see you in 2 weeks.
Yeah, thanks for joining, everyone.
Thank you, everybody. Thank you, team.
Hey everyone, thanks for watching. If you enjoyed this video, please let us know by liking and subscribing. If there's another topic that you'd like to learn more about, leave us a comment. We would love to hear from you. And if you want to become a coding pro, visit our website at codingnomads.co. See you next time.